Hello and welcome to my video presentation of my science fair, which is finding speed of light using food. So I will start out with introduction. So the whole point of this project was to find the speed of light using food, which is easily could be found in anyone's house. And what interested me in this topic would be how does the light travel and could it be accurate when trying to find it at home without inexpensive equipment that are used in labs. During the process, there were some questions and problems that I faced, which would be could speed of light be accurately found through the process of using food, and how does the whole process works? So the purpose of this research will be finding the most accurate speed of light with food, and I use 4 different types of food, and also what type of food can find the most accurate speed of light. So the materials are pretty easy. So the first being microwave. Also, I use 3 types of chocolate from 3 different companies, both of them being dark and milk chocolate. And then also pack of marshmallows. I had mini and big ones. Also a pack of American cheese, a ruler, a calculator, and 3 egg whites. So the research of this project will be that the speed of light in vacuum will be 299,792,458 miles per second. Also, the light in air is much slower than light in vacuum. In theory, nothing could be faster than light. Also, microwave is a form of electromagnetic radiation, which we're going to use today. Also, the hot spots that we're going to use in order to find speed of light are caused by peaks of 2 waves matching up. The microwaves have a long wavelength, but not long as radio waves. The frequency are waves that pass a fixed place in a given amount of time. And nodes are points in wavelength that seem to be still. Also, antinodes means the point in wave that has the highest velocity in y direction are hotspots, which we're going to find today. So my hypothesis for this project will be since the microwave produces electromagnetic radiation, then by using those data from melted food, we can find the approximate measurement of speed of light. However, of course, different food types might give us different results. However, I believe most of the time they're going to fall in the same range. But I do believe that chocolate might perform just a little bit better than the other foods, just because of its size and how flat it is. The variables in the experiment will be that the independent variable will be the food types that I'm going to use today, while the dependent variable will be the speed of light. Also, the control variable will be the wavelength and the frequency of the microwave used and how long I will put the food in the microwave. So the whole procedure seems a little bit long, but it's fairly easy. So the first thing we're going to do is taking out the rotating ring in the microwave in order to measure the wavelength. And then after, we're going to take our chocolate, which is placed on a plate, and then insert it into the microwave. After everything we have set and prepared, the microwave is set for 30 seconds and we just wait. After, we remove the plate with chocolate and then record the distance between 2 hotspots. And in order to do that, we have to multiply by 2, since that's going to be the full wavelength. After taking all the measurements, in order to find the whole speed of light, we're going to take a look at the microwave and see the frequency, which is mostly written in the back of the microwave or in the front, depending on your microwave. So mine was 2,450 megahertz, and then we're going to multiply by a million in order to get it converted to hertz. After getting both our hertz and length of the wave, we're going to multiply and get our speed of light. And in order to find the percent of error, we'll take our accepted value, which is the speed of light in vacuum, and then subtract the value that we got from the chocolate or any other food type that we're going to use today, and then which is also the experimental value, and then divided by the accepted value, which is again the speed of light in vacuum. After the first try, we're going to redo it with 2 remaining chocolates. And then also we're going to do the same procedure with the other ingredients and food types that we're going to use today. So this was my table for chocolates, and it shows all the calculations, and the time that I set for today will be 30 seconds, and the 3 different hotspots that was on the chocolate, and also it also states the food item that I use, which is chocolate of course, but it also mentions the company names. And then the frequency, it's similar for everything. And it also shows the calculation of percent of error. So for this, we can see that the chocolate milk chocolate has the least percent of error comparing to the two remaining ones. So this chart shows for the marshmallows, and I used two of my tries are for mini marshmallows, while one of the first ones is the big marshmallows. And again, the time is set for 30 seconds, and the frequency is the same, and it shows the calculations, the speed of light, and also percent of error. As you can see, the mini marshmallows first try of it was the least, it has the least percent of error out of all the three ones. Of course, also cheese. I use the same exact cheese for all three tries, which is American cheese. And again, the time is the same, the frequency is the same, and it shows the calculation and the hotspot distance, and of course the percent of error. For this particular one, actually, both of the American cheese, the second and the third try, has the exact percent of error. Then the remaining one, however, it is the biggest one so far out of all the other ingredients. And of course, our final ingredient will be egg whites. So I use the same egg whites for all three of the tries. And again, the time is the same, the frequency is the same. It shows the hotspot distance and the calculations, and also percent of error. We can see that the percent of error, the first try is the least percent of error, and the comparing the remaining two other ones. So I have a chart that includes every food item that we use for today. So it goes from the chocolate, marshmallows, cheese, and egg whites, and at the end, it's the accepted value, which is speed of light and vacuum. So as we can see, the closest being will be egg whites, the first try, and the chocolate milk chocolate, and also the mini marshmallows, the first try. So my observations for this experiment was that marshmallows was the hardest ingredient to find the hotspot on, since there was so much in it. It was not only one marshmallows, but there was a scatter around on plate. However, the mini marshmallows ended up being the most accurate, but also including chocolate milk chocolate and the first try of egg whites. The chocolate, like I expected, was the easiest to spot the hotspot. There were some reactions from the egg whites while being microwaved, and also the marshmallows puffed up a bit when taking out of the microwave. Also, I like to mention that the cheese results were almost exactly the same. So in the end, my analysis was that the most accurate food being the chocolate milk chocolate, the mini marshmallows, the first try, and the egg whites, first try, while the least accurate being the cheese, first try. And in the end, the least accurate of all of the food categories was the American cheese, while the second accurate food were Hershey chocolate and also the big marshmallows and the egg whites, second try. So in conclusion, my hypothesis was half correct, since one of the chocolates, chocolate milk, was one of the most accurate ones, but also it included the egg whites and the mini marshmallows that were one of the accurate foods, which I didn't guess right. Since it was kind of shocking, because initially I didn't think that the marshmallows would be very accurate. The practical application for this experiment will be the simplicity of it, because since it's so simple to do at home that we can do any day with almost anyone in the household. You can do with your kids, with your friends, and most of those food could be found in your pantry or in your house or anywhere else, and seems fairly easy. So this is my bibliography. This is the continuation of the bibliography. And that will be all for my experiment and my project. Thank you so much for your attention. I really appreciate it.